In this lesson, we want to think about applications of quadratic equations. So throughout our study of algebra, we often come across word problems or application problems. So far in our course, we've only discussed word problems that involve solving a linear equation in one variable. Now we're going to go one step further and take a look at some word problems that involve quadratic equations. So I want you to recall that we have a little 6-step procedure that we can use for solving word problems. And although we've introduced this method for use with applications of linear equations, we can also use it in this section as well. So let's just kind of recap this 6-step procedure. I think you'll find it useful if you write it down and kind of go through the steps when you're solving the problem. So solving a word problem, we have that our first step is to read the problem and determine the question or perhaps questions to be answered. You always want to make sure that you understand the question, or again, the questions that you're being asked to kind of answer. It helps you kind of format things in a way, well, what am I trying to find? Then the second step is to assign a variable to represent the unknown. And in some cases, we're going to have to express other unknowns in terms of this variable. Then third, we want to write an equation that describes the scenario we're given. And then fourth, we're just going to solve that equation. Then fifth, we want to write the answer in terms of the question, or again, perhaps questions asked. And then the sixth thing, probably the most important, we want to check the answer using the words of the problem. And we want to make sure that the answer is reasonable. Okay, you're going to see in some of the examples we get today, we're going to have some solutions to our equation that we set up that don't quite work in the context of the problem we're given. Okay, and we'll get to that later on. All right, so the first few problems we're going to look at are going to involve the Pythagorean formula. I know that most of you already know about the Pythagorean formula, but just in case you don't, it doesn't hurt for a little bit of a review. So the Pythagorean formula basically shows the relationship between the lengths of the sides of a right triangle. So again, we know we have a right triangle because of this signature mark here. This is telling us we have a 90-degree angle or a right angle. Okay, so if you have a right angle in a triangle, it's known as a right triangle. Now, with a right triangle, we have this special relationship between the sides. Okay, so you have these two shorter sides known as legs. You have this here leg A, which is this kind of vertical measure here. And then you have this leg B, which is this horizontal measure here, okay? And then you have C, which is the hypotenuse, okay? The hypotenuse is always going to be opposite of the right angle, so opposite of this, and it's the longest side. So most of you already know this. The Pythagorean formula tells you that A squared, right, which is basically the measure of leg A, that guy squared, plus B squared, again, the measure of B, leg B squared. If I sum those two amounts together, it's equal to C, which is the hypotenuse, that measure, squared. Okay, this is your Pythagorean formula, and it's true for any right triangle that you come across. So using this Pythagorean formula, basically, if we don't know one of the sides of a right triangle, but we know the other two, we can solve for the unknown. Okay, so let's take a look at our first sample problem. All right, so Jason needs to wash a window in a building that is 12 feet from the ground. To avoid a fence, he decides to rest the ladder against the building. For stability, Jason decides he should place the ladder 9 feet away from the building. How long of a ladder will Jason need? Okay, so the first thing we need to understand, again, is what am I being asked to find? And in this case, it's this little question here, right? So how long of a ladder will Jason need? So we'll just highlight that. That's what we're trying to find. So when we go to assigning a variable, we're just going to let x represent exactly what we're trying to find, which is the measure of Jason's ladder. And this is going to be in feet because we're working with feet in the problem. So let's go down here to a fresh sheet. We're going to say that we're going to let x be equal to the measure of Jason's ladder and of course, this is going to be in feet. Okay, so in feet. All right, so I'm not going to write feet every time. I'm just going to work with the number parts. We're just going to understand that we're working with feet. All right, so to help us understand what's going on, we have this little illustration here. It's not perfect, but it'll just give you an idea of what's kind of happening in our problem. So when we started out, we said that Jason wanted to wash a window in a building that is 12 feet from the ground. So this guy right here, this represents our window. Okay, that's in our drawing. And basically you could say that it's 12 feet from the ground. So from right here to right here, that measurement, let me kind of draw a little vertical line. Okay, not perfect, but it'll have to do. So this guy's going to be 12 feet. Again, I'm just going to put 12. And then also, it tells us that for stability, Jason decides he should place the ladder 9 feet away from the building. So the ladder, we can't see it because it's hidden in the grass, but let's just say it's about right there. So from right there to right here, let me use a different color. So from right there to right here, that horizontal measure is going to be 9 feet. So let me again just draw a little horizontal line. Okay, again, not perfect, but you get the idea. So this guy is 9 feet. I'm just going to put 9. And I can put my little symbol here. This is going to be a right angle. So I've got that symbol there. So we have a right triangle, right? We have that this guy here, this horizontal leg is 9. This guy right here, this vertical leg is 12. And I'm solving for this guy right here, which is the length of his ladder. This is exactly what I need to find. I could just put this as x right here. This guy is going to be the hypotenuse, okay? So essentially I can say that, again, for my Pythagorean formula, a squared plus b squared equals c squared, where a and b are the lengths of the two shorter sides, or the legs, right? So we know that's 9 and 12. So we just plug in and say that we have 9 squared plus 12 squared, okay, and it doesn't matter the order that you do that in, is equal to, instead of c, I just have x, so I'm going to say this is x squared, okay? So 9 squared we know is 81, plus, we know 12 squared is 144, this equals x squared, and 81 plus 144 is, of course, 225. So we get that x squared, okay, x squared is equal to 225. So we can solve this with our square root property. We know that x would be 15 or negative 15, right? Take the square root of each side. So square root of this side is equal to plus or minus the square root of this side. And let me kind of scroll down to get a little bit of room going. And we can basically say again that x is equal to plus or minus 15. Now, does it make sense? Okay, does it make sense for the measure of this ladder to be negative 15? No, it's nonsense. Okay, so that's where, checking your answer when you think about kind of the steps we gave makes a lot of sense. So if you incorrectly said that the ladder could be 15 feet or negative 15 feet, when you go to check that, you can say, okay, that doesn't make sense, right? A ladder can't measure negative 15 feet. That's complete nonsense. So you just have to throw that solution out and say that x, or the kind of length of the measurement of that ladder, is going to be 15 feet, okay? So I'm just going to write that in there and say this is 15, or again, 15 feet. So let's go back up. And again, we can just kind of write a little sentence to describe our answer. So how long of a ladder will Jason need? Well, we'll say that Jason needs a ladder. Jason needs a ladder that is 15 feet long. Okay? So checking this is really, really easy. Again, we just go through our Pythagorean formula. And it's easier to check something like this by looking at the picture again, just so you get an idea what's going on. Again, we said that with Jason, he needs to wash a window in a building that's 12 feet from the ground. So this is where the window is, and this is where the ground is. So the distance from here to here, that's 12 feet. Okay, so that's where we got the 12 from. And then to avoid offense, he decides to rest the ladder against the building. So that's why this ladder is drawn in this manner, okay? And then basically it says that for stability, Jason decides he should place the ladder 9 feet away from the building. So from here to here is 9 feet. That's where we got that 9 from. Okay, so this part all checks out. So then we're asked, how long of a ladder will he need? Well, again, we see that we have a right triangle, and so we can use our Pythagorean formula. We plugged in, we got 9 squared plus 12 squared equals x squared. X was the length of the ladder. And so we got 81 plus 144 on the left side of this, which is 225. So we ended up with x squared equals 225. We took the square root of each side, right? And we found that we had x equals plus or minus 15. We threw out negative 15 because it didn't make any sense. So that's how we got our solution, where we said that Jason needs a ladder that is 15 feet long. Okay, so this solution is correct. All right, let's go ahead and take a look at another one. So we have that Larry and Steven were both parked in the same parking garage. Larry leaves first and drives north at 50 miles per hour. 1 hour later, Steven leaves and drives east at 70 miles per hour. How long after Larry starts driving does it take for the two cars to be 290 miles apart? So again, we want to understand the main question, and here it's just to find how long after Larry starts driving does it take for the two cars to be 290 miles apart. So for this problem, we're going to end up using our Pythagorean formula, and we're also going to use the distance formula that we see with motion word problems, right? The distance equals the rate of speed times the amount of time traveled. All right, so before we kind of get into that, though, we need to assign a variable to represent the unknown. In this case, we're going to end up having kind of two unknowns because we don't know how long Larry's going to drive for, and we also don't know how long Steven's going to drive for. Okay, so what we're going to do is, since Larry leaves first, we're going to say that X is the amount of time that Larry drives for before the two are 290 miles apart. Okay, so let's go down here to a fresh sheet. And I'm just going to say we're going to let X be equal to the amount of time. And I'm just going to put for Larry. Okay, and we know what that means. It's going to be specifically in hours, and it's going to be the amount of time that Larry drives for before, again, the two cars are 290 miles apart. Now, for Steven, we can kind of base his time on Larry's, right? We know Larry's time is X. Well, for Steven, we know that 1 hour later, Steven leaves. So he's been driving for an hour less at this point when they are 290 miles apart. So I can just go X minus 1 to represent Steven's time. Okay. So we're going to say then, I'll do that in a different color. So we'll say then X minus 1, this quantity is the amount, again, of time for Steven. Okay, we'll just make it nice and simple like that. You could write out something that's really long and say it's the amount of time for Steven, in hours before they're 290 miles apart, but you kind of get the idea, and we want to make it as short as possible. All right, so the next thing we want to do is just come down to a little table, just organize our information so that we know what's going on. So our distance formula, in case you forgot, the distance traveled, which I'm going to say is D, is equal to the rate of speed, which is R, multiplied by the amount of time traveled, which is T. Okay, so the rate of speed is in miles per hour, the time is in hours, and the distance is going to be in miles. Okay, and then we have two participants here. We have Larry, and then we have Steven. Okay, so those two guys are involved in the problem. So what information do we have? Well, we know the time because we said that Larry's going to be driving for X hours when the two are 290 miles apart. And we said that Steven, since he drives an hour less, is going to be driving for X minus 1 hours, again, when they're 290 miles apart. Now, the rate we can get directly from the problem. It tells us specifically that Larry leaves first and drives north at 50 miles per hour. So this 50 miles per hour is going to be his rate of speed. And then for Steven, he leaves and drives east at 70 miles per hour. So 70 is going to be his rate of speed again in terms of miles per hour. So let's just fill this in. For Larry, it's going to be 50 miles per hour. For Steven, it's going to be 70. Now, if I have a rate of speed and I have a time, I have a distance, right? Because I can just multiply. R times T gives me D. So 50 times X is 50X. And that's my distance that Larry's going to travel, again, when they're 290 miles apart. So for Steven, he's going to have traveled 70 times the quantity. Remember, this is a quantity and this is multiplication. So put parentheses. So times the quantity X minus 1. And you can go ahead and simplify this now because you're going to have to later. You can just say this is 70X minus 70. So we'll write this as 70X minus 70, just so that we have it ready to go. Okay, so before we kind of set up our equation, I want you to think about something, because usually at this point, people make a drastic mistake. They're used to kind of solving these in another scenario, kind of with the opposite direction travel. With that one, they end up saying, okay, well, the distance Larry travels, which is 50X, plus the distance Steven travels, which is 70X minus 70. They sum those two amounts and they say, okay, well, that's got to be equal to 290, okay? This is wrong. This is what we saw kind of earlier in the course. This is not the current setup, okay? What we have here, and just to kind of illustrate what's going on, I drew a little picture, a little illustration. And basically what we have, again, is another application of the Pythagorean formula, because we end up with something that is a right triangle, okay? So we have that Larry is driving north. So you can picture him starting from here. Let's just say that's the parking garage. And he drives north, which on every map that you look at, that's basically going up. Okay, so this is going to be a vertical leg for the right triangle. And we know that measure, the distance, if I go back, is going to be what? It's 50X. So let's go back here. And I'm just going to write this in as 50X. And we know that's for Larry. So I'm just going to put a little arrow here and say that's L for Larry. Okay, that's his distance. That's, again, from here to here. That's the point he's going to be at when these two guys are 290 miles apart from each other. Now, for Steven, let me put a little S here and go this way. He's got this horizontal leg. So this guy to this guy, that distance there, again, if we go back up, that's 70x minus 70. So let me put this here as 70x minus 70. Okay, so you can obviously see what's going on here. We've got our two legs for this right triangle. And again, the formula is that a squared plus b squared. Okay, we square each of the legs and we sum those amounts together. And this is equal to the hypotenuse squared. So c squared, again, normally this is c. But in this case, we have kind of expressions involved. So we just kind of plug those in and work with those. So we end up with, let's just say 50x, that quantity squared, then plus this guy is the quantity 70x minus 70. The whole thing is squared, so make sure you wrap it in parentheses. And this equals our c, or our hypotenuse, is going to be 290. So that amount, that's going to be squared, okay? So we're going to just copy this and go to a fresh sheet because we'd run out of room here because this is going to be quite tedious. So let's just paste this in here and let's get started. All right, so for 50x squared, if we wanted to simplify that, I would need to square 50 and also x. So that would give me 50 squared times x squared. Now, 50 squared is 2,500. So let me just replace that and say it's 2,500. Okay, so then plus. Now, don't make the mistake of doing this. A lot of students, again, I've said this throughout the course, they do what? They say this is 70x squared minus 70 squared. Okay, that is wrong. This is wrong. Don't do that. Remember, if you have something in here with addition or subtraction, you've got to expand it. Okay, remember our special products formula. You can use that here to do this pretty quickly. You're going to square the first guy, which is 70x, that whole thing squared, right? So the whole thing is squared. So it's 70 squared, which is 4,900, times x squared, okay? Then you're going to have minus. You're going to have 2 times this guy times this guy. So it's 2 times 70x times 70. Okay, and we'll just go ahead and crank that out real quick. 2 times 70 is 140. Then times 70 again would be 9,800. So basically what you'd have is minus 9,800x here. So minus 9,800x, or you could say 9,800x, whatever you want to say. And then lastly, you need to take this 70, the last term there, and square it. So we're going to go plus 70 squared, we already know is 4,900. So this is 4,900. Okay, so that's this side right here, and this equals 290 squared is 84,100. Let me slide this down so I can fit this all in one line. So 84,100. Okay, so we have kind of some big numbers involved here. So let's do some simplifying, and then I'll show you what we can do to kind of make this as easy as possible. All right, so 2,500x squared plus 4,900x squared, those are like terms, so we can combine them. So if I had 2,500 and 4,900, I get 7,400. So this is 7,400x squared. Then minus 9,800x, I can't do anything with that as of yet. So we'll just leave that as it is. And then what I can do over here, I'm going to subtract 84,100 away from each side of the equation. Okay, and what that's going to do is that's going to give me 0 over here on the right side. Okay, because I'm solving a quadratic and I want it in the format of ax squared plus bx plus c equals 0, so I can use my quadratic form. Okay, so 4,900 minus 84,100 is going to give me minus, or negative, 79,200. Again, this equals 0. Now, if you want to plug these into the quadratic formula as they are, you can. Most of you, I know pretty much all of you are going to be using a calculator. I'm using a calculator. If you're working with bigger numbers or smaller numbers with a calculator, it doesn't really matter, right? It does the calculation for you. But just to make this a little easier, a little simpler. So what we'll notice here is that each of these numbers ends with 2 zeros. This guy over here is a 0, so it's not going to matter. But if they all ended 2 zeros, they're divisible by 100, right? So if I divided every part of this equation by 100, on the right, 0 divided by 100 is still 0, so that's fine. Basically, I would just knock 2 zeros off from everything, right? So that makes it a lot simpler, right? You have 74x squared minus 98x minus, and this comma would disappear. You'd have 792, and this equals 0, okay? Perfectly mathematically legal to do that. And you would notice that you could also still divide each part by 2. So if you wanted to make it even simpler, you could say that 74 divided by 2 is 37, so 37x squared. And then 98 divided by 2 is 49, so minus 49x. And then minus, if you take 792 and you divide by 2, you would get 396. And we can say this is equal to 0. Okay? So this is a lot simpler, a lot easier to work with. So let's kind of drag this up here and see what we got now. So we're going to use our quadratic formula. So again, this is going to be A, this is going to be B. Okay, it's the whole negative 49. And this is going to be C, again, the negative 396. Okay, and I circled the negative ones because sometimes you get confused and you try to just take the number part without the sign. When it's positive, obviously it doesn't matter, right? You're not bringing a sign with you. It's just positive, so it doesn't have a sign in front of it. All right, so with the quadratic formula, again, in case you have forgotten it, x is going to be equal to the negative of b plus or minus the square root of, you've got b squared minus 4 times a times c. This whole thing is over 2a. So all I'm going to do is just plug in. Okay, very, very easy. So for negative b, again, b is negative 49. The negative of negative 49 is 49. Plus or minus, you've got b squared, so you'd have negative 49 squared. So let's just go ahead and do that real quick. If I square negative 49, I get 2,401. So let me write that in. 2,401. That's kind of hard to fit in there. So let me redo this. So square root of 2,401, again, minus 4 times. For A, I have 37. And then for C, I have my negative 396. And we can crank this out now or come back in a minute. Let's just come back in a minute. For A, we have what? We have 37, so let's plug that in there. All right, let's do our calculation. So negative 4 times 37 is negative 148. Then times negative 396 is going to give me 58,608. So let's just put plus 58,000, again, 608. If we sum 2,401 and 58,608, we get 61,009. Okay, so let's write that there. So 61,009. Then down here, 2 times 37, we know from earlier is 74. Okay? All right, so what is the square root of 61,009? Well, if you punch that up on a calculator, you're going to get 247. So let's erase this and put 247. Now, we have two cases here, but you're going to see that one of the cases ends up being nonsense, right? Remember, we're solving for x, which is the amount of time that, in this particular case, Larry's going to travel for or drive for before the two cars are 290 miles apart. So you know that you can't have a negative amount of time. That wouldn't make sense in this scenario. I can't say, well, he drove for negative 18 hours, as an example. Okay, what does that mean? It doesn't mean it's nonsense, so you have to throw it out. So the one of these guys that's going to make it negative, we would just immediately exclude that, okay? So the first scenario would be that x is equal to 49 plus 247 over 74. So we keep that one. The other scenario is what? It's x is equal to 49 minus 247 over 74. This is going to end up being negative, so you can just throw this out, okay? You don't need to worry about that solution at all. So focusing on this one, 49 plus 247 is 296. So if you had 296 over 74, you would have 4. Okay, so nice and simple. So x equals 4. Again, that tells me that Larry drove for 4 hours before the two cars were 290 miles apart. Again, x was the amount of time for Larry. X minus 1 was the amount of time for Steven. So this guy is 4 and this guy is 3, right? Because 4 minus 1 is 3. So again, to officially answer this, how long after Larry starts driving does it take for the two cars to be 290 miles apart? We'll say Larry drives for 4 hours before the two cars are 290 miles apart. Okay, and if you want to check this, again, it's easy to go to the diagram and kind of visually see what's going on. You want to mark down some information that Larry's going at 50 miles per hour and Steven's going at 70 miles per hour. So let's go to the little drawing we have, and let's see if we can make sense of this. We can erase all this. We can actually leave the a squared plus b squared equals c squared. We'll actually use that. So if I plug in a 4 for x, I'd have 200. So that's for Larry. We know that he drives 200 miles from here to here, and that's basically over the span of 4 hours, and that's how far he's going to have traveled when he gets to this point here when they're 290 miles apart. And then for Steven, you can plug in a 4, which is what x is. You get 70 times 4 is 280. 280 minus 70 is 210. Or you could, again, do it kind of manually and say, okay, well, he was going 70 miles per hour. He only drove for 3 hours. 70 times 3 is 210. So either way, you get 210 as his distance from here to here, okay? So again, we know about the right triangle. If this is 200 and this is 210, plugging in, if one is 200 and the other is 210, if we sum those two squares, it should be this guy right here squared. So is that true? 200 squared is what? Well, punch that up on a calculator, you're going to get 40,000, okay? 210 squared, punch that up on a calculator, you're going to get 44,100. And if you sum those two amounts together, you are going to get 290 squared, because that's going to be 84,100, okay? You can easily see that. 40,000 plus 44,100 is 84,100. So we can say here our answer is correct. Larry drove for 4 hours before the two cars were 290 miles apart. All right, so another common type of problem in this section involves finding an unknown area. So generally speaking, these problems are going to deal with some type of rectangular shape. This could be a pool, it could be a garden, it could be a quilt. The example we're going to see next is going to be a rug, okay? So something rectangular in nature. So what I want to cover really quickly is just the formula for the area of a rectangle. So we have a rectangle on our screen, we have our length, and we have our width, okay? So the area of a rectangle, we'll put A here, is equal to the length, which I'm going to put capital L, times the width, which is capital W, okay? So that's the formula for the area of a rectangle. You might want to write that down because we're going to use it immediately in the next problem. So just as a quick example, suppose I said that the length here was 8 inches, and suppose I said the width here was 6 inches, okay? And I said, well, what's the area of this rectangle given this information? Well, the area, I'll just put capital A, is equal to what? It's 8 times 6, which is 48. You're just multiplying. And then inches times inches, you multiply your units. That's going to be inches squared, or you could say square inches. So we're going to say this is 48 square inches, okay? And let me make this Q a little bit better. Okay, so again, 48 square inches when we have a length of 8 inches and a width of 6 inches. All right, so again, let's put this formula to immediate use. So we have here for our sample problem that Jamie wants to put a rug in a bedroom that is 15 feet long and 12 feet wide. She wants to leave a strip of uncovered floor that has a uniform width around the rug. After looking at pricing information, she decides that she can afford to buy a rug with an area of 108 square feet. Okay, so what are the dimensions of the rug? So again, what are we being asked to find? Well, given the fact that she can afford to buy a rug that has a maximum area of 108 square feet, we want to know what are the dimensions of the rug, okay? Well, to solve this problem, if you haven't seen it before, it might be a little challenging for you to kind of set it up, okay? So usually what you do with this is you draw a little diagram, and I have that already set up. And what you'll see here is that the entire rectangle is meant to represent the bedroom, okay? And then you have this kind of smaller rectangle, which represents your rug. And then the brown you see, that's the strip of uncovered floor, okay? That's around the rug, okay? And that's actually the key to understanding this problem. So when we go back up, I just want to read this part one more time. She wants to leave a strip of uncovered floor that has a uniform width around the rug. This is very important. So this uniform width around the rug, okay? Let me go back down, and we're just going to label a few things. So what do we know? We know the length of the bedroom, or the measurement from here to here, is 15 feet, okay? That's given in the problem. We know the width, the measurement from here to here, is 12 feet. That's given to us in the problem. We also know that this kind of strip of uncovered floor has a uniform width. So in other words, I know from here to here, and then from here to here, and from here to here, and from here to here, this is all going to be the same all the way around. The width is all the same, okay? So the key to this problem is letting a variable like x, or whatever you want to use, represent that uniform width for that strip of uncovered floor, okay? So I'm just going to say this is x, this is x, this is x, and this is x. Okay, so given the information that we have now, can you see how you would set up and find the dimensions of the rug? Okay, so for the rug, we want to know what's the length and what's the width. Well, for the length, I know the length of the bedroom. It's given to me, it's 15 feet, so that's from here to here. If I want the length of the rug, Well, I need to subtract out kind of from here to here and from here to here, okay? So what's that measure? And I kind of went over there, so let me draw that a little bit better. So what's that measure? Well, it's going to be 15, the total amount, minus this, which is x, okay? This is x, and then minus this, which is x. So 15 minus x, which is going to be 15 minus 2x, okay? So that's going to be my length of the rug. Now, for the width, it's a similar thought process, okay? The width is going to be from here to here. And again, I just want to think about the width of the whole room, which is 12 feet. So I'm just going to put 12 there. And I want to subtract out this guy right here, which is x. And I want to subtract out this guy right here, which is also x. So 12 minus x is 12 minus 2x, okay? So now I have a length as an expression, 15 minus 2x, and I have a width as an expression, 12 minus 2x. So let's copy that real quick. And I'm just going to paste that there. And what we know from our problem, it tells us that she can afford to buy a rug with an area of 108 square feet. So we're going to assume that that's what she buys. So my length times my width gives me my area. So what I'm going to do is I'm going to say 15 minus 2x, that quantity, that's my length, multiplied by the quantity 12 minus 2x, that's my width. This should equal my area, and we're told that the area is 108 square feet. So I'm just going to put 108, okay? So I'm going to solve this equation for x, and that's going to allow me to find out what is the length and what is the width for my rug that Jamie has, okay? So 15 minus 2x times 12 minus 2x, we're going to use FOIL for that. So 15 times 12 is 180. And then 15 times negative 2x is minus 30x. Negative 2x times 12 is minus 24x. If I combine like terms, I'm going to have negative 54x, so minus 54x. All right, so then we have negative 2x times negative 2x, which is going to be plus 4x squared. And then this is just equal to 108. Okay, so let me kind of rearrange things here. Let me put this as 4x squared minus 54x plus 180 is equal to 108. Now, what I want to do is subtract 108 away from each side of the equation so that I can have 0 on the right side. And I can go ahead and use my quadratic formula, or you could factor, whatever you want to do, okay? So in this case, I'm going to have 4x squared minus 54x, and then plus 180 minus 108 is going to be 72. This equals 0. Now, if you want to do this, this is an optional step. You don't need to. You can divide each part here by 2. Okay, that's going to give you smaller numbers to work with. So if I divide this by 2, this by 2, this by 2, and this by 2, I'm going to get 2x squared minus 27x plus 36 equals 0. Okay, that's just something I did to give us smaller numbers to work with. Again, completely optional. All right, so now let's use our quadratic formula. Again, you can solve this one with factoring, but I'm going to use the quadratic formula. So this guy right here, this is going to be A. This guy right here, this is going to be B. This guy right here is going to be C, okay? So I'm going to plug into x equals the negative of b plus or minus the square root of, you've got b squared minus 4ac, the whole thing's over 2a, okay? So the negative of b is negative 27, so just plug that in there. Then b squared, you've got negative 27 squared. 4 times a times c, a is 2, c is 36, and then a again is 2. Okay, so we filled all this in. Now we can just kind of crank it out. The negative of negative 27 is 27. Okay, so that's easy enough. Negative 27 squared is 729. So this would be 729. Negative 4 times 2 is negative 8. And then negative 8 times 36 is negative 288. So this is basically minus 288. If I do that calculation real quick, I'm going to get 441, right? 729 minus 288 is 441. If I took the square root of 441, I would get 21. Okay, so this is 21 here. And then 2 times 2 is 4. Okay, so we're going to get two answers. You're going to find that one of them doesn't work, but we'll get to that in a minute. So 27 plus 21 is going to be 48. 48 divided by 4 is 12. So x equals 12. And then also 27 minus 21 is 6. 6 over 4, you can say that's 3/2 or 1.5. So let's take these back to our illustration. And we're going to see if they make sense. Okay, so let me paste this up here. So can x be 12? Remember, I'm plugging in for x in each case. So I'm plugging in here and here. Well, 2 times 12 is 24. 15 minus 24 is negative. Okay, it's going to be negative 9. Does it make sense for this rug to have a length of negative 9? Okay, no, it can't be negative 9 feet. That doesn't make any sense. It's nonsense. So you get that when you solve these problems. You just have to reject one of the solutions. So go ahead and throw that out. Okay, you can't use that. Can we use 3/2? Yes, we can. 3/2 is 1.5. If you multiply 2 by 1.5, you get 3. Okay, so what you'd have in each case, you could just replace this with 3 and this with 3. 15 minus 3 is 12, so that's the length of the rug. And 12 minus 3 is 9, so that's the width of the rug. Okay, so we basically found our answer for our problem. So what are the dimensions of the rug? We'll say that Jamie's rug, okay, Jamie's rug has a length of 12 feet and a width of 9 feet. Okay, is that consistent with what we're told in the problem? Well, 12 times 9 is 108. Feet times feet is feet squared or square feet. So that does match up with this, okay? But you can also check to make sure that it is consistent with the rest of the problem. So when we come back to our little illustration, again, we just want to check that this 1.5, this figure matches up with what we got, right? So this 1.5 is the width of this strip of uncovered floor, which has a uniform width. It's supposed to be the same all the way around. So it's 1.5 all the way around. Let me write that like this. Okay. So does that make sense? Well, if the length or the measurement from here to here is 12, and I add 1.5 for this and 1.5 for this, well, yeah, 12 plus 1.5 plus 1.5 is 12 plus 3, that's 15. That's this guy right here, the length of the bedroom. Okay, so that makes sense. Same thing's going to happen for the width. So the measurement from here to here, we know that's 9, then plus another 1.5, plus another 1.5. 9 plus 3 is 12. Again, that's given to us in the problem. So that checks out. And we already checked the fact that the rug matches up and it gives us 108 square feet. So we can basically say we're good to go. This rug has a measurement of 12 feet for the length and 9 feet for the width. All right, so let's wrap up the lesson and talk about another common problem you see in this section. We're going to be dealing with the height of a propelled object in feet. So when we get to this section, we basically have a little formula that we work with. If air resistance is disregarded, the height of an object that's propelled directly upward can be thought about with this formula. So we have h is equal to negative 16t squared plus v sub 0 times t plus s sub 0. So when you're in this section in your algebra course, you're going to be given this formula. They're going to give you stuff to plug in, and then you're going to have to solve for something, okay? So h is the height of the projectile in feet, t is the number of seconds, v sub 0 is the initial velocity in feet per second, and s sub 0 is the initial height in feet. So when we're talking about height, if I get a height of 0, that means I'm on the ground, okay? If I get a height that's positive, let's say it's 50, let's say for h, again, it's 50, that means I'm at a height of 50 feet in the air, okay? If I get an initial height in feet, it's the same thing. If I got 50, that means I'm launching from 50 feet. All right, let's look at a sample problem. I think you'll find this to be very, very straightforward. A toy rocket is launched vertically upward from an initial height of 500 feet. The initial velocity is 20 feet per second. Find out how long before the rocket will hit the ground. Okay, so obviously we're just answering this part right here where it says to find out how long before the rocket will hit the ground. We're just going to take the formula. Let's go back for a second. And we're going to grab this guy, and I'm just going to rewrite it right here real quick. So h is equal to, you've got negative 16t squared. And you got to be careful here because the t gets confused with a plus sign. So I'm going to put that in a different color. So plus, you've got your v sub 0 times t, or you could say t times v sub 0. So let's put v sub 0 times t. And again, you've got another plus sign, so let's do that in a different color. And then you have your s sub 0. Okay, so this is your formula that you're working with. Now, we can plug in a lot of information here. It says that the initial height is 500 feet. S sub 0 is your initial height. So you can just go ahead and erase this and put 500 there. And then it says the initial velocity is 20 feet per second. So that's this v sub 0 here. So I'll erase that and put a 20 there, okay? So now we have two variables involved. I have h and I have t. But it says find out how long before the rocket will hit the ground. We already said that when the rocket hits the ground, h is 0, right? That's the height. So I can just replace h with 0, And all I have here is a standard quadratic equation, right? So I have negative 16t squared plus 20t plus 500. If I replace t with x, it's going to look very familiar for you, okay? And I'm not going to keep it this way. I'm going to keep it with t because that's consistent with our formula. But if you were struggling and you couldn't kind of grasp what's going on, just replace it with x, solve it, and then go back and replace that for t, okay? Not a big deal. So I can solve this using the quadratic formula. I can also solve this particular one by factoring. What I'm going to do to make this a little bit simpler, I'm going to divide everything by 4, just so we have smaller numbers to work with. So divide this by 4, this by 4, this by 4, and this by 4. I'm going to get, and I'm also going to kind of rearrange things. So I'm going to get negative 4t squared, then plus, I'm going to have 20 over 4 is 5, so 5t, and then plus 500 divided by 4 is 125. This equals 0. Okay, let's go ahead and plug into the quadratic formula. So we know that what? We know that this guy right here, this negative 4 would be A. We know this guy right here, this 5 would be B, and this guy would be C, okay, this 125. So instead of x, we have t, so we're going to say t is equal to, you've got the negative of b. B is 5, so negative 5, plus or minus the square root of, you've got b squared. Again, b is 5, 5 squared is 25. Minus 4 times a is negative 4, times c is 125. And I'll do this in a minute. This is over 2a is negative 4, so 2 times negative 4 is negative 8. Okay, so negative 4 times negative 4 is plus 16. So let's just put plus, you'd have 16 times 125. That's going to be 2,000, okay? So 25 plus 2,000, you do this all in one shot. This is 2,025. If you punch up square root of 2025 on a calculator, you're going to get 45. Okay, so this guy is 45. Now, one of these solutions you're going to throw out, okay, because we're solving for t, which is time. So it's got to be a positive value or 0. Okay, it's basically got to be non-negative. If you end up with something like negative 800 seconds, what does that mean, right? It doesn't mean anything. Again, it's nonsense. We've seen that throughout this kind of lesson. If you get something that doesn't make sense, just reject it, throw it out, okay? So the first one would be negative 5 plus 45. So let me kind of do that over here. So t equals, so negative 5 plus 45, which would be positive 40 over negative 8. This would end up giving me negative 5 seconds, which again doesn't make sense. So we're just going to throw that solution out. Okay, we don't need it. Then t is equal to, the other one is negative 5 minus 45, which would be negative 50. And then divided by negative 8, negative over negative is positive. I can also simplify by dividing each by 2. So this would end up being 25 fourths. Now, in decimal form, that's 6.25, and that's what we're going to use. So let me erase all this. We don't need any of it anymore. So find out how long before the rocket will hit the ground. Well, we found that it's going to happen at 6.25 seconds, right? So we'll say that the rocket will hit the ground at 6.25 seconds, okay? And again, a very, very easy problem. Very, very easy if you get this question on homework or tests. You just plug into the formula and you're basically just have to set up your quadratic equation and solve. Okay, so how about checking something like this? What would we do? Well, again, we just go through the formula again. It's h is equal to, we have your negative 16 times t squared. For t, I've got 6.25. Again, I can plug in a fractional form here to make it a little simpler. So I'm going to put 25 fourths, this guy squared. Then plus v sub 0, the initial velocity was 20. So we're going to put 20 times, you've got your t, which again, I'm going to put 25 fourths for that. And then you've got plus your s sub 0, which is 500. That was the initial height in feet. So that's 500 feet. Okay, so h is supposed to be 0. So we just check this, make sure we got the right answer. So let's go back down. So 25 squared is 625, 4 squared is 16. So this would be 625. I'm going to write that a little better. So 625 over 16. This guy's going to cancel with this guy and give me a negative 1. So this would basically be negative 625 here. And most of you can already see this is going to work out. This cancels with this and gives me a 5. 5 times 25 is 125. So basically what you have is 125 plus 500, which is 625. And then that's being added to negative 625, so that does give you 0, right? You end up with 0 equals 0. So this is consistent with what we're told in the problem. So we can say here that our answer or our solution is correct. the rocket will hit the ground at 6.25 seconds.